training the data for a full tree. So you want to grow the tree to the maximum possible extent. And then you start pruning the tree back to what we want. So the way to grow the tree to the fullest extent is to specify some control parameters. And the control parameters we will use are CP and min split. Okay, so we have to, this is the full tree is given in figure 9.10. So I use CTRL 9.10. So that's for figure 9.10. Okay, and then the R part control. CP, okay, that is your complexity parameter. Yeah, we saw this in PowerPoint notes. So that's your error rate. Okay, error rate plus alpha times the number of nodes. So you'll always have, okay, if you keep branching, your error rate will always go down. It will always go down. But it goes down at the cost of adding one more node. So you add a penalty, which is k times alpha. Alpha is a constant. So if the reduction is very marginal, then the penalty that you're adding is going to, more than compensate the improvement in error rate. So it's going to be more than a wash. So you're not going to continue growing the tree. So that's the idea. Now, so if you set CP equal to 0, so that means the improvement that you want is 0, which means you're going to keep on branching without end. Okay. So, and then we have to also specify min split. Okay, min split, otherwise the default value is 5. So even if you put CP equal to 0, the min split of 5 will make sure that you stop when the node reaches 5 observations. It's not going to split anymore. So if you want to grow the tree to the fullest extent, then you have to specify min split equal to 1. So that means it's going to keep on splitting until there is only one observation. Of course, if you have only one observation, you're not going to be able to split anyway. Okay, so this will ensure that the tree grows to the fullest extent. Back dot tree dot full. Okay. Then we say R part personal dot loan. Okay, and the model is all variables, and then data equal to train .df. Okay, the method equal to class. Okay, and then control equal to R CTRL 9.10, which is done. Okay. So this is going to compute or develop, it will grow the tree to the fullest extent, and then we will print it back tree dot full type equal to 1 extra equal to 2. So extra, if you add 100, it'll use type 2, extra equal to 2, and then it will add percentages. Okay. PRT should be that. have a row there. Okay, so you see that it has lots and lots of nodes. So this is the full tree. Because full tree is not a useful tree because it's going to fit. You know, the if you look at the error graph, you know, you have gone way past where an optimal tree should be. Okay. So now let's look at pruning. No, I'm not going to do the confusion matrix. We know how to do all that, and I have that in the PDF file. So you can take a look at that. Okay. So we want to now prune. So how do we do the pruning? Avoid overfitting. Here are the parameters that you can use in Prune. Okay. And so we take the so let's say that Prune tree. Okay, so we take we use the prune okay. So prune method, so you give the full tree, so that's the tree we want to prune, and then you can specify parameters that you want. You can say, I want to prune the number of trees, number of nodes equal to, so whatever. Okay, so we can say, so these are the parameters that we have. Maximum depth. Okay. Depth of any node in the tree. The default is 30. The minimum split. Okay, default is 20. CP equal to, so the parameter, cost complexity parameter. Okay. And so on. So you can give any parameter that we want. So suppose if you say, I want to prune to CP equal to 0.02. Okay. And then print the pruned tree. So that's going to give you the pruned tree with CP equal to 0.02. So it takes the fully grown tree and prunes it back. So that CP, the cost complexity is no more than no less than 0.02. Okay. All right. So we can print. So that is a method called print CP. Print CP. Okay. So if you use print CP for the full tree, so it gives you the CP value, the N split value, relative error, and X error and X SVD. So these are for different tree sizes. So here, this is the root node. And then we have a tree with 2 splits, tree with 3, 4, and so on. And it does not give you the whole list. It just prints you only selected values. Okay. So this is one way of trying to find the optimum pruning. Okay. So you can always arbitrarily come up with a maximum depth or minimum split or a particular value for CP. But if you want some objective measure of comparison, then what we can do is we can look at this table, okay, where the relative error is 1 minus R square. And relative error is used only for regression tree, so which means the target is a numerical value. It's not a classification value. Now, X error is your misclassification error, or cross validation error. Cross validation error is if you use cross validation, if you take the misclassification error from each of those folds and average them. So that's your cross validation error. So it gives you the cross validation error. Okay, for classification problems, we need to look at the X error. So one way of doing this is to look at the X error, okay, and look for the smallest X error, smallest cross validation error. And the CP value corresponding with that smallest misclassification error. Then use that CP for pruning back instead of coming up arbitrarily with the CP value. You look for the smallest X error and select the CP value from that. Okay, let's look at an example of that.